Okay, so the surface area of a pizza box is 45,000 centimeters squared. Find the dimension of the optimal pizza box. So in this case, again, you're looking for that word optimal, right? That tells you you're going to have to optimize. What shape would optimize? A cube. Yeah, a cube. So that means, and then since I'm giving the surface area formula, what do I? Yeah, so I have to start with the surface area of a cube. Okay? So the surface area of a cube is 6s squared. What do I know? I know the surface area. So I can plug in the surface area here. And then I can isolate for s. Right? How do I isolate for s? What do I need to do? What's the first step? That's your last step. The first step is you want to get rid of the 6. Okay? So first you're going to have to divide by 6. Then you're going to have to square root. Okay? So divide by 6, then square root, what do you get? Okay, so you divide it by 6 first, and then you square root, so 9.3 centimeters. So if it's 9.3 centimeters by 9.3 by 9.3, that's going to give you your optimal shape. Guess what? This is not going to fit a pizza. But anyway. So the optimal, well, that's going to give you the maximum volume, right? The optimal dimensions for...
Why didn't we start with surface area for the first question? What was the
I will
difference?
answer that question in 1 second.
Okay.
In this case, they gave me the surface area, so I have to start with the surface area. In the first question, they gave me the volume.
Oh, yeah.
So I have to use the volume. So whatever they give you, that's the formula you start with.
Okay.
So something that I might add up to this question would be part B. The maximum volume or the optimal volume. What would you do to find the optimal volume now? Use the volume equal S cubed. Yeah, and then actually put the 9.3 because that's your optimal dimension. Put it in and find your volume, right? And that's going to be your maximum volume you're going to ever get for that surface area. Why do I have a feeling that this is too small? I just want to make sure that
I got.
this seems too small. I got 86.6 for this. Do you guys not get that? Try it again. Yes? You got that now? And then the volume is going to be 649,461.
What is put the first answer in the calculation?
So
go for the 45,000, the
So you do the square root first, and then you can do this, right? And then you can put 45,000, and then 6. Or, if you want, you can do 45,000 divided by 6, and then find the answer, and then do square root of the answer. Either way would work. Did you get that now?
I got 27.3
Are you doing square root or cube root?
square.
Okay, let's try that again.
Oh, I didn't put enough zeros, sorry, my bad.
Okay. All right, are we okay with this? So, whenever we're dealing with rectangular prism, your optimal shape is a cube. Are we clear on this? Now, my next shape that we're going to optimize, and these are the only two shapes that we're going to optimize, is the cylinder. Okay? So anything that's like a can, pop, right? They put it in a cylindrical shape can. So when we're dealing with cylinders, the optimal dimension always occur when the height is twice the radius.
Sorry, could you go back for a second? Where did you get the n to define max volume? Sorry.
Sorry.
No, what did you get for the max volume? Okay.
For the maximum volume is 64946.1.9. So, when we're dealing with a cylinder, the height should equal to twice the radius. Okay? So it should equal to the diameter, basically. All right? That will give you the optimal shape for a cylinder. Okay? So, let's recall the formula for the surface area and the volume of a cylinder. So what I want you to do, on your green sheet, tell me what is the surface area of a cylinder and what's the volume of a cylinder. So what's the surface area of a cylinder?
2 pi r squared plus 2 pi r h.
And what's the volume? Pi r squared h?
Yeah.
Okay. Now, let's see what happens if I replace the h with 2r. Okay? Because I know that the height should equal to 2r with my optimal volume, or with my optimal cylinder. Okay? So what I'm going to do, look here, eyes on me for a second. You're going to sub in 2r for h. You know why we're subbing in 2r for h? Why are we subbing in 2r for h?
Oh, because 2 radiuses.
Because of this, right? That's going to give me my optimal option. Okay? Because h will give me, is equal to 2r, will give me the optimal option. So, I'm going to replace h with 2r. So I have 2 pi r squared plus 2 pi r times 2r. Okay? So you see right here, this h, I replaced it with 2r. Are we okay with that? Now, let's simplify this. So I have 2 pi r squared plus 2 times 2 is 4. So that's 4 pi. R times r is, so 2 times 2 is 4 pi. R times r is r squared. Are we okay with that? Now I have 2 pi r squared plus 4 pi r squared. Can I simplify this?
Is that a y?
That's a 4. What's 2 pi r squared plus 4 pi r squared? Can I simplify that? 6 pi r squared, right? So that means my surface area for the optimal cylinder is 6 pi r squared. Now you're going to have to remember this, or you're going to have to know where to refer to, what formula sheet, the lesson that you need to refer to, okay? Because that's not in your formula sheet. Okay? So this is the optimal surface area formula. We're going to do the same thing with the volume formula. So I'm going to replace the height with 2r. Okay? So pi r squared times 2r. And that would simplify to 2 pi r cubed. And that's going to be the formula we're going to use for the optimal volume of a cylinder. So remember, guys, if you look here for a second, look at me. So if you look at this formula here, you had the radius and height. Both of them are unknown. Okay? So you had the radius and height. In the formula right here, in the optimal formula, I only have radius. Okay? The height is not an unknown anymore because it's with relation to the radius. Let's see how we can solve a question like this. So the surface area of a can of soup is 154.6 centimeters squared. Find the optimal dimension of the can. So optimal, okay? This is your keyword. This is when you know that you're going to have to look for your optimal formulas. Now, I'm given a surface area. What formula do I start with? The surface area formula, right? Which is this one. So the surface area is 6 pi r squared. Now, how do I know that it's a cylinder? Because it says it's a can, right? A can is a cylinder, all right? So in the question, because when you're going to do the assignment, it's going to be either a cube or a can or a cylinder. Okay, so you have to be careful. I know the surface area is 154.6, and I'm looking for the radius. What do I do to find the radius? How do I isolate for that radius? What do I have to do? Divide by 6 pi. By 6 pi. By 6 pi. You want to get rid of the 6 pi. So divide both sides by 6 pi so you can get rid of this, right? So be careful when you're putting this in the calculator. Make sure that you either put like literally 6 pi. If you're going to put 6 times pi, you're going to have to put it in bracket. Okay? So make sure that you put it as 6 pi in the calculator. And the answer is 8.2. How do you find the radius now? Square root. So the radius is 2.9. So my optimal radius is 2.9. But for a cylinder, I need radius and height, right? So I found the radius. How can I find the height? Use that h equals 2r, right? So to find the height, you just multiply the radius that you just got by 2. So it's going to be 5.8 centimeter. It's a word problem, so I have to end the word problem with a therefore statement. So I'm going to say, therefore, the optimal dimension of the can are a radius of 2.9 centimeter and a height of 5.8 centimeter. Are we okay with this? So, always they're going to give you either a volume or a surface area. And it depends on which one they give you, then you start with the formula. So let's look at the last question.
Oh, one second.
Yeah. So, the volume of a Pringles container is 1800 centimeter cube. Find the optimal dimension of the container. Again, optimal dimension, right? This is where I know that I'm maximizing 1 minute. So, what formula do I start with? The volume formula, which is, what was it? 2 pi r cubed. So my volume is 1800. How do I find the radius? What do I do first? Divide by 2 pi. Yeah. And to find the radius, you just have to square root, or sorry, what do you have to do? To find the radius, what do you have to do?
Cube root.
Cube root. So cube root, and that's going to be 6.6 about. I found the radius. Did you get that? Okay. So that means now I have to find the height. The height is twice the radius. So it's going to be 2 times 6.6. And that is going to be 13.2. And now you can write a therefore statement. If I want to add a part to this question, what would it be? If I want to add another part to this question, if I want to add this question to this question, what would it be? Find the minimum surface area, right? And then what do you need to do to find the minimum surface area?
2 pi r squared.
Mm-hmm.
6 pi r?
You can use either or because now you have both the radius and the height, right? If you want, you can, the easier one to use would be this one, right? And then just plug in whatever radius you got. Don't forget to write your therefore statement. Okay? Any questions about this? So remember that you're always Minimizing surface area, maximizing volume. Is that clear for everyone? All right.
So wait, which surface area formula is defined?
It doesn't matter which one you use, it should give you the same answer. Okay? Because you already have your height and you have your radius. So it doesn't matter which one.